We'll be reading Chapter 7, Section 2, Erosion and Deposition. As you have learned, erosion is the process that transports Earth's materials from one place to another. A number of different agents transport weathered materials on Earth. Running water in streams and rivers, glaciers, winds, and ocean currents and waves all pick up and carry material. Humans, plants, and animals also play a role in the erosional process. Erosion can result from the loss of plant cover as shown in Figure 711. The land becomes barren and as increasing amounts of soil are lost to wind and water erosion. At some point, the movement of transported materials will slow down. When this happens, the materials are dropped in another location in a process known as disposition, the final stage of the erosion process. Gravity's role in erosion. Gravity is associated with many erosional agents because the force of gravity tends to pull all materials downslope. Without gravity, glaciers would not move downslope and streams would not flow. Gravity is also an agent of mass movements such as landslides, mud flows, and avalanches, which you will learn about in Chapter 8. Erosion by running water. With the exception of the extremely strong winds associated with tornadoes and hurricanes, water has more power to move large particles of weathered material than wind does. As you might expect, extreme erosion is greatest when a large volume of water is moving rapidly, such as during spring thaws and torrential downpours. Water flowing down steep slopes also has greater potential to erode Earth materials because the steeper the slope, the faster the water flows. Not only does swiftly flowing water have greater erosional power than wind, but it can also carry more material along with it and over a greater distance. Running water moves along Earth's surfaces from higher to lower elevations. Small streams at high elevations flow down to join larger streams at lower elevations. Such a network of streams drains an area called a watershed as the water works its way down toward the ocean. The erosion by running water is in small channels on the side of slopes is called rill erosion, shown in Figure 712a. Rills commonly form on a slope. When a channel becomes deep and wide, it can evolve into gully erosion, as shown in Figure 712b. Gullies can be more than 3 meters deep. They can be a major problem in farming and grazing areas. Coastal disposition and erosion. Rocks exposed to their surrounding environments are slowly weathered away. As molded in the mini-lab on this page, each year, streams and rivers carry billions of metric tons of sediments and weathered materials to coastal areas. The Mississippi River alone carries 750 million metric tons of eroded material off the continent and into the Gulf of Mexico annually. When a river enters a large body of water, such as the ocean, the water slows down and deposits large amounts of sediments. The buildup of sediments forms deltas, such as the Nile Delta, shown in Figure 713. The volume of river flow and the action of tides determine the shapes of deltas, most of which contain fertile soil. Coastal areas also undergo erosion by ocean waves and wind. You will learn more about coastal erosion in the Science and Environment feature at the end of this chapter. In the ocean, weathering and erosional processes continue. The work of ocean currents, waves, and tides carves out cliffs, arches, and other features along the continent's edges. In addition, sand particles accumulate on shorelines and form dunes and beaches. Erosion of materials also occurs along the ocean floor and on continental and island shorelines. The constant movement of water and the availability of accumulated weathered material result in continuous erosional processes, especially along ocean shorelines. Sand along an ocean shoreline is repeatedly picked up, moved, and deposited by ocean currents. In this way, sandbars form from offshore and sand deposits. If the sandbars continue to be built up with sediments, they can become barrier islands. Many barrier islands, as shown in Figure 714, have formed along the Gulf and Atlantic coasts of the United States. Erosion also occurs on islands, where the constant movement of water wears away at the shorelines. Changing tides and conditions associated with the coastal storms can have a great impact on coastal erosion as well. Human development and population growth along shorelines have led to attempts to control the ocean's movement of sand. However, efforts to keep the sand on one beachfront distribute the natural migration of sand along the shore, thereby depleting sand from another area. Figure 7.15 shows one method used to help prevent beach erosion. You will learn more about ocean and shoreline features in chapters 15 and 16. Glacier erosion. Although glaciers currently cover less than 10% of Earth's surfaces, their erosional effects are large-scale and dramatic. Glaciers scrape and gouge out large sections of Earth's landscape. Because they are so dense, glaciers have the capacity to carry huge rocks and piles of debris over great distances. Glacial movements scratch and grind some surfaces while they polish others, as shown in Figure 7.16. The landscape features left in the wake of glacier movements include valleys with majestic waterfalls, lakes, and various shaped deposits of sediment. Such features are common in New England. The erosional effects of glaciers also include deposition. For example, soils in the northern sections of the United States are deposits of material once carried by glaciers. In these and other ways, glaciers continue to affect erosional processes on Earth. Even though the time of the most recent ice age is long past, you will learn more about glaciers in the next chapter. Wind erosion. Wind is a major erosional agent in the areas of Earth that experience both limited precipitation and high temperatures. Such areas typically have little vegetation cover to hold soil in place. Wind can easily pick up and move these fine, dry particles. When conditions become ideal for wind erosion, the effects can be dramatic and devastating. The abrasive action of wind-blown particles can damage both natural features and human-made structures. Wind erosion is common in Death Valley. Figure 7.17 is in Death Valley. Shore areas also experience wind erosion. Even though wind can blow against the force of gravity and easily move materials uphill, wind erosion is relatively insignificant when compared to the erosion accomplished by running water and glacier activity. Wind barriers. One farming method that reduces the effect of wind erosion is the planting of wind barriers, also called windbreaks. Wind barriers are trees or other vegetation planted perpendicular to the direction of the wind. In many cases, a wind barrier may be simply a row of trees along the edge of a field. In addition to reducing soil erosion, wind barriers can trap blowing snow, conserve moisture, and protect crops from the effects of wind. Erosion of plants, animals, and humans. Plants and animals living on the surface of Earth also play a role in erosion. As plants and animals carry on their life processes, they move Earth's surface materials from one place to another. For example, Earth's materials are relocated as animals burrow into soil and shovel it to another place. Humans also excavate areas and move soil from one location to another. Planting a garden, developing a new athletic field, and building a highway, shown in Figure 7.18, are all examples of human activities that result in the moving of Earth's materials from one place to another. The effects of erosion by the activities of plants, animals, and humans, however, are minimal in comparison to the erosion effects of water, wind, and glaciers.